Yes. Hello, everyone. Teacher Samuel here. I'm a chemistry teacher and a mentor. So, welcome to our today's session where I want to take you through ionic bonding, where I want to show you how ionic bonding is established in compounds, and some of the tips the student can employ to understand ionic bonding. We're also going to look at some examples and, of course, a few properties that are important when it comes to ionic compounds. So welcome. Let's work this. There are some two particles on my left hand side. The lithium, which is positively charged, and the fluoride, which is negatively charged. Because from the name itself, ionic bonding, it's all about ions chemically combining to form a compound whereby the ions are joined together by what we are calling the ionic bonds. So as a student, it is very important that we're able to understand the issues around compounds because they are going to assist you. What are some of the areas we are going to cover in this session? Number one, we are going to describe the types of elements that are involved in ionic bonding. These are simply the metals and the non-metals, as we shall see. Number two, we are going to explain the role of the valence electrons in ionic bonding. And number three, we are going to look at the properties of ionic compounds. So to start off, ionic bonding revolves around metals and nonmetals. So as a student, it's very important that you're able to understand and comprehend the arrangement of elements on the periodic table. This is a very important grid because it provides a lot of information when it comes to valences, chemical symbols, which are very important in writing the compounds that has ionic bonds. There are some bonus tips that students should be able to master when it comes to writing of ionic bond. Number one, a student should be able to write the correct chemical formula of the compound in question. Number two, to be able to establish the number of each atom that make up the compound, knowing the correct electronic configuration of each element. And most importantly, how each of these elements is able to form an ion, whether it's a cation or an anion. So the question now is, what's ionic bonding? To assist you understand this concept, it's important that students be able to know it's about metal and a non-metal reacting to form an ionic bond. But how the question is, how do they combine? So metals are going to become stable by losing electrons. In the process, they become positively charged, what we call a cation. On the other hand, we have the nonmetals that are going to form ions by gaining an electron. In the process, is what we now refer to as the anion. So, in simple terms, we can say ionic bonding, it is just a force of attraction that exists between a cation and an anion. In fact, we refer to it as the electrostatic force of attraction because it's between charged particles. It's also important that I note It is a very strong force of attraction, bearing in mind you're bringing in particles that are oppositely charged together. So how is a cation formed? So on my display, I have what we call the lithium, and on the other hand, I have the lithium ion. So as you can see, we know the configuration of lithium. So the configuration of lithium is so lithium, we know it is 2.1. So it must be able to lose its outermost electron to become a lithium ion, which is now positively charged with 2 electrons in its outermost energy level. So what we have here is a lithium ion, which now is our cation. Negative ions are formed by nonmetals through gaining of electrons, where they become negatively charged. So as you can see in fluorine, before gaining an electron, the configuration is it is 2.7. Sorry for that. It is 2.7. But now it has to gain this electron, it becomes 2.8. So in the process, our fluorine is now stable, now becomes a fluoride ion. So our first example is sodium chloride, and we are going to start off from the name itself. We talk about sodium chloride. Sodium chloride, the formula is NaCl, meaning from the name, the way it's ending, it's made up of 2 elements, that is sodium and chlorine. So the first thing you as a student are able to do is to know how many sodium atoms are there, how many chlorine atoms are there. In our case, we can be able to see we have 1 sodium ion and 1 chlorine ion, 1 chloride ion, sorry. So we need to know their configuration. So we know that sodium, it is 2.8.1. Our chlorine, it is 2.8.7. So for it to become an ion, our sodium must be able to lose its outermost electron. And in the process, the occupied energy level is lost. So we are going to have now our sodium ion, which is 2.8. Similarly, our chlorine is going to gain an electron and it becomes a chloride ion with a configuration of 2.8.8. So simply what is happening, we have the sodium transferring its outermost electron to chlorine. In the process, our sodium becomes sodium ion. Our chlorine that has gained now becomes a chloride ion. Remember, all of these 2 ions now are stable. So they now come together now to form what we have on our display. We have our sodium ion. This is our sodium ion. And this is our chloride ion. So we now have a force of attraction that is joining our 2 ions together. And that is simply what we call ionic bond. So that is why I started by saying there is a misconception that most students tend to believe that ionic bonding exists between a metal and a non-metal. But in real sense, it is between the cation from the metal and the anion from the non-metal. And that is how we're able to show the ionic bonding in sodium chloride. We can also have another example. Sorry for that. We can look at lithium. So lithium oxide. We can look at this together now. So the name suggests it is lithium oxide. So the first question now is, what is the valency of lithium? So no, lithium is a group 1 element. So lithium has a valency of 1. Because the name ends with IDE, that means there are 2 elements. The other element is oxygen. What is the valency? So we have the chemical symbol as O. Oxygen has a valency of 2 because we have lithium as 2.1, oxygen 2.8.6. So when lithium loses 1 electron, the valency becomes 1. Oxygen must gain 2 electrons, so the valency is 2. So the first thing we do is to write the chemical formula for lithium oxide. So what we do, we are going to exchange their valencies. So under lithium, we shall get a 2, and under oxygen, we shall get a 1 from lithium. So that becomes the correct chemical formula for lithium oxide. So we want to try now write the formula. So we shall have our lithium. So looking at this, we can be able to know, to see that there are 2 lithium atoms. So because of that now, our formula becomes lithium oxide. So there are 2 lithium atoms combining with 1 oxygen. We don't have to draw the individual lithium atoms as well as the oxygen atom. What we need to do is just go straight and draw the 2 lithium. So we shall start with the first lithium. We'll draw using the nucleus to show it's lithium. Then it has 2 remaining electrons, so we can pair them up. And in this case, our lithium has lost 1 electron, so it becomes positively charged. But now we go back to the formula. There are 2 lithium atoms. So we are going to put a number 2 just before our lithium. Then we go to our oxygen. It's supposed to gain 2 electrons to become stable. So we shall have our oxygen, then we have the nucleus, and we show the distribution of electrons. I can use a dot. There are 6 of them initially, and I like using this format so that when it comes to pairing them up, it becomes very easy. So one of the electron from the first lithium and the other electron from the other lithium. So with that, it also becomes negatively charged. But how many electrons has our oxygen gained? 2. So that means our charge becomes 2 minus. So in other words, in between these two, between the lithium ion and the oxide ion, that is now where we have our ionic bond. That is where it exists. You see, it is between whatever is a cation and an ion. So, and in simple terms, that is how we can be able to show ionic bonding in lithium oxide. And one thing we are going to realize is that once we form our compound, we shall have our lithium now, which is now positively charged with 2 electrons in its outermost energy level. We shall also have our oxide, which is now negatively charged, the minus, 2 minus the charge, and the configuration becomes 2.8. You see, all of them have become stable. And that is simply how you can be able to show ionic bonding in lithium oxide. So just similarly like what we had, that is what we have. So we've been able to show step by step on how they are able to arrive at this. So, and that is how we can be able to show how we're able to get our lithium oxide. So all those compounds that are going to have ionic bonds, they have a structure which we call giant ionic structure. It is simply ions that are joined together in a regular and a repeating pattern, to be able to form one big structure. And because it's made up of ions, that's why we are calling it a giant ionic structure. So any compound that we can imagine of made up of a metal, we can have a few examples. You can have the likes of magnesium chloride. You can have the likes of aluminium oxide. We can have the likes of calcium bromide. We can have the likes of calcium oxide. Any compound that is made up of a metal and metal that are joined together, they form what we call ionic compounds. So all of them will have a giant ionic structure. So these giant ionic structures, they have some key properties. And one of the properties is that they are good conductors of both heat and electric current. And the reason is because, they only conduct electricity when they either are heated, that they melt, or they have been dissolved in water, what we say is in aqueous state. They simply do this because if you take an example of maybe sodium chloride, if you take an example of sodium chloride, and assuming we heat, so we are going to make free the sodium ions, now in liquid state, plus the chloride ions, now we say they are in molten. So in simple terms, we can say now in this stage, our ions are free, or they are mobile, or they are now delocalized. Alternatively, we can also have the same solid. Remember, this is the solid. And now you can be able to bring in water. So what you are going to have, we are going to make our chloride ions. They are going to be free. So again, now they're in aqueous stage. But something we are going to realize that in solid state, these ions exist in what we call fixed state. So they cannot move. That is why ionic compounds are only going to conduct electricity only in either molten state or aqueous state, because we are saying in this state, then we are saying the ions are free. So number two, we are going to realize that they have high melting points. You see, ionic bonds exist between positive and negative. So that makes them very strong. So to break them, then that means we require a lot of heat to break. That is why I find that any compound that contains ionic bonds will tend to have very high melting points and boiling points. So there are some questions you can be able to attempt at your free time. So you can be able, with that information you have done, can be able to look at how you can show magnesium nitride